Hello and welcome. In this video, I'm going to complete a series of tasks on MPLS on OcNOS devices. The task is as follows. Configure route leaking between two VRFs. What I mean by route leaking is we need to make sure that the route targets are going to be configured in a way that we can reach to other routers, other customers' prefixes. And in this case, of course, we are going to configure this between ABC and Globetrotter, and we are going to do it in a way that they can reach to the prefixes of Alex. Now, in my case, of course, I have not configured ABC. That's okay. Whatever we are going to do for Globetrotter is going to happen on ABC as well. So that's okay, and you can just replicate it yourself. I have kept ABC for a specific purpose, and I'm going to use it later. But here we have Alex and Globetrotter, and ABC, Globetrotter is going to be able to reach the prefixes on Alex. So for this, what we are going to do is a series of tasks. First of all, you should know that Alex has some static routes. We need to configure those static routes as well. Globetrotter is not going to have a specific configuration because it is using a routing protocol. So we need to make sure that this is going to happen, and also there are some configuration that we need to do on the PEs, which is going to be R1 and R5 on both of them. Now, how can we make sure that one customer can reach to other customer, or maybe say that these two customers are both partners, or there is an acquisition or merger happening between them, or maybe for some reason this is the same customer but we are kind of separating them from each other for some reasons, and now we need to make sure that they have the reachability in place. So what can I do for that? We have route targets. Route target means where these prefixes are going to be exported and which prefixes I'm going to import into my routing table, and we are going to play with these in here. Now, I have spoken about this in previous videos a lot, so I encourage you to take a look at those videos, but I'm going to show you the overall configuration here, and during that, of course, I'm going to explain a little more so that you can understand what is happening. So if I just go to router 1 here, what I'm going to do is to say show run, and I'm going to just show the whole running configuration. So what you see here is I have configured IPVRF GT and I have IPVRF Alex in here. Each one of them have a route distinguisher. Route distinguisher is like a mark on the stuff that you have, and all of those stuff go into the same bucket. Based on those marks or tags that you are adding to them, you can just tell which one is for who. But this part is not so important. The second part is going to be important for our case, the route target. Route target says that where can I get the information from, where can I send the information to. So what I'm telling here is this. I have two customers in my case, for example. This is customer 1, which has another site in here. This is customer 2, which has another site in here. And let's say that we just mark them with some numbers just for simplicity. What I'm going to do is to say this is, let's say 1, and this is 2. And let's say that these are route targets, and I'm just going with what number, not with a double-sided number like this, without a colon, just for the sake of simplicity. And let's say that this is marked 3, and this is marked 4. Maybe there is another one which is like this one. Let's say I'm going to go with another color just for understanding, 5. So how can I configure these in a way that, for example, 2 has reachability to prefixes on 1 and 1 has reachability to prefixes on 2? This is using route targets. Route target is going to be our policy to get to the other side. And in this policy, on this side, I'm going to say, okay, I am 1, but I am needing, I need to get to site 2, so I'm going to import all the prefixes from that into me. And because 2 needs to reach to my prefixes, then I'm going to export my prefixes here to that. So I'm going to export number 1. The same thing happens on 2. 2 says that, okay, I am importing 1 because every prefix on there, I needed to reach to that, and I'm exporting 2. So this is what we have here. But on the other side, let's say that this is a configuration. This is a routing protocol for internet. Maybe there is just not routing protocol, routing table for internet. And maybe on this routing table we only have one default route or multiple prefixes. Doesn't really matter. Because we want to have reachability on site 1 and site 2, what we are going to do is to say we are going to need that as well. So we are going to import 5 as well. Okay, so this is my policies on here. The same thing goes on here. So here I'm going to say import 4, export 3, and here of course I'm going to import 5 as well. The same thing goes on here. I need to import 3, export 4. Also I need to import what? 5. Okay. What if I want to have route leaking between customers? Then what I need to do is to say, okay, I want to reach this site 2, then I need to get 2 as well. So I'm going to import 2, and because the other side should know about my prefixes a little bit at least, whatever that I want to send, I need to say, okay, I'm going to import 3 as well. So with this, we just play with different values just to get information from the other side. Now, what I have done, of course, is this. I have just configured one side as the other side, and the import export, of course, are the same. For example, I have marked this with 1, the other side with 1. So that's not going to make any difference in the logic. But if you want to be very granular, so what you need to do is to just make sure that the route targets are different on each one of these sites. So there are benefits and disadvantages for each one of these approaches. You just take a look at your design and see what you really need, and then do the configuration. So what I'm trying to do is this. I need to go to here and change the values a little bit. So I'm going to say Control C, and I would say that because we want to have reachability to the other side, I'm going to import 6 as well for Alex, and import 5 for this GT. So I'm going to do that. So let's just go to here, go to configuration mode. I'm going to say IPBRF GT. I'm going to say import. We want to have import 5.5 and import, not, let's say route target import, of course. I just forgot to say that. Route target import 5.5 because we are exporting 6, so there is no need for that. And then I'm going to exit this, and I'm going to say IPVRF Alex, and I'm going to say route target import, of course, going to be 6.6. So I'm going to commit this, and I'm going to again say show run, and now you can see that on VRF GT I am importing from Alex, and on VRF Alex I'm importing from GT. So we are going to be okay in this case. I'm going to do the same thing on the other side, so this is just a matter of copying and pasting to the other side to router 5. So I'm going to say this, and that's it, and I'm going to say commit. Now, the Alex case is a little bit different from Globetrotter. On Globetrotter, we have a routing protocol that is, sending and receiving every prefixes here. But in Alex case, of course, what we have is static route. Now, Alex knows the static routes for the other branch of Alex, so there is no problem with that, but it doesn't have any static routes toward Globetrotter. So let's do that. On router 12, I'm going to check my prefixes. So here, if I say show IP, so let's say show run raw interface look back, you can see that I have only 12, 12, 12, 12. And what I'm trying to do is to configure a static route towards this. And also on router 13 and router 13, yes, that is for Globetrotter. Show run interface loopback says that we have 13, 13, 13, 13. So I'm going to go to router 1. Previously, we had a static route configured here. So if I just say show run, and I'm going to say include IP route, you can see this is a static route that we have configured. I'm going to add the new prefix here. So what I'm going to do is to say, not on this, of course, because this is towards Alex. So I need to go to Globetrotter as well. So I need to go to router 12. And in here, I'm going to say show run, include IP route. So I don't have anything, but I have it on router 10. So if I just go to here and say OcNOS, and EN, and show run, include IP route, you can see that I have configured this towards that destination, which is router 1. I need to configure the same thing here, IP route, because I want to go to 12, 12, 12, 12 slash 32. I need to go to 10, 1, 10, 1, because it knows about that. And also the same thing for 13, 13, 13, 13. So I need to configure that as well. So 13, 13, 13, 13, and commit the configuration. Okay, I need to do the same thing on the other side on router 11, which is the other Alex network. So on router 11, I'm going to say OcNOS. I'm going to say show run, include IP route. And you can see this is what we have, but we need to add these two lines as well. Of course, not these two lines. Let's say abort transaction. What I need to do is to say, to reach to this, we need to go to 10, 5, 11, 5, and also the same thing about this. To get to this, we need to go to this. Now I'm going to commit the configuration. Okay, now that we have done this and route leaking is in place, we can check the reachability. So if I just say on Globetrotter, of course I want to do that because here we have the static routes, and if I just say do show IP route, it will not show anything other than the static routes that we have configured here. But on Globetrotter, which is router 12, now I should see some routes here. So if I say show IP route here, you can see that I have 10, 10, 10, 10, and 11, 11, 11, 11. So what I'm going to do is to say do show IP route, but not just any IP route. What I'm going to do is to say VRF Alex. On VRF Alex, as you can see, I have the prefixes for 10, 10, 10, 10, and 12, 12, 12, 12. And as you can see, this is marked with V, which stands for VRF leaking. So this means that we have reachability to that. And also the other thing is going to be VRF GT. And as you can see, we have VRF leaking for 10, 1, 10, 0, which is this network. And also 10, 10, 10, 0, which is this one. So VRF leaking is done here. The same thing should be done on router 5 just to make sure that we have reachability. So if I just say do show IP route, VRF Alex, we have VRF leaking correctly set. And also if I just go for GT, we have this as well. So one more time, if I just check the reachability on any of these, I should be able to reach to other sides. So from 10, for example, so on R10, if I just say ping, let's say 13, 13, 13, 13, which belongs to Globetrotter on the other side, and I'm going to source it from my loopback. It says 10, 10, 10, 10. I have the reachability and route leaking is done perfectly. So everything is working just fine. I hope this has been informative for you, and see you in next videos.